Hello, my name is Professor Adjovan, and this is episode 6 of the Quadratic series. In this episode, we're going to start talking about factoring with a simple but very important part of factoring, and that's factoring a greatest common factor, or GCF. We're going to look at 3 examples in this video. The 3 examples are on your screen now, so if you're doing problems that look like this, then this video will help you out. If you're looking at these problems and you think you already know how to do them and you're confident in your abilities, then I recommend that you go on to the next episode in this quadratic series. For everybody else, let's go ahead and jump into it. As usual, before we jump into the actual uh, polynomials and factoring out a greatest common factor from them, let's take a step back and recall some old information that will be useful with these current problems. So what I want to do is called prime factorization. Meaning I want to take a number, in this case 84, and I want to break it down into its prime factors. So 84, we can pick any 2 things that multiply to make 84. It's an even number, so I can pick 2, and 42, they multiply to make 84. 2 is a prime number, so we are done with this branch. 42 can be 2 and 21. 21 can be 3 and 7. And now all of my ends of my branches, we'll call them, are prime numbers. So I could rewrite 84 as a product of all of these primes. I could rewrite it as it's 2 times 2 times 3 times 7. Or I could simplify this even more and say it's 2 squared times 3 times 7. This idea and this skill is going to come in handy to factor out a greatest common factor from something like 18 squared minus 21x. So what I want to do is look at 18x squared. You know what, let's look at the 18 by itself. And let's do the prime factors of it. Let's do what we just did. 18 can be 3 times 6, and 6 can be 2 times 3. But this isn't just 18, it's 18x squared. Well, x squared is x times x. So what I'm going to do is rewrite this 18x squared as 2 times 3 squared, because I have 2 3's, times x times x. And what about the negative 21x? Well, 21 can be 3 and 7, but this is negative 21, so I need to make one of these a negative, doesn't matter which one. And then negative 3 can be negative 1 and 3. I want to make sure that I get that negative out of here and get it as a negative 1. So I can rewrite negative 21x as negative 1 times 3 times 7 times x. So this top one is 18x squared. This bottom one is negative 21x. What I want to do to find the greatest common factor between these two is look at everything that these have in common. I see a negative 1 in the bottom, no negative 1's in the top. I see a 2 in the top and no 2's in the bottom. I have 2 3's in top, and on bottom I have 1 3. So I'm just going to circle them. I have a 7 on bottom and no 7's on top. And then I have a single x on bottom and 2 x's on top. So I can circle one set of those. So what I've circled, a 3 and an x, is what they have in common. And that's going to be what we can factor out. That's going to be the greatest common factor. So 3x is my greatest common factor. But because we're factoring, I need to have what's left. What is everything that's left? Well, what's left of the 18x squared? There's a 2. There's still a 3 left because there was 2 of them here, and an x. So 2, 3, and x. Well, 2 times 3 is 6, times x is 6x. I'm left with a 6x. What's left from the negative 21x? Negative 1, 7. Negative 1 times 7 is negative 7. Alright, so starting with 18x squared minus 21x, we did a prime factorization for both of these terms. We identified what was alike in both of the prime factorizations, and what was alike was our greatest common factor. We then took each of the pieces that was remaining and rewrote it in parentheses so that we could have 2 factors. Let's do another one. In this case, I have 3 terms. We're going to have to do 3 prime factorizations. I'm going to start with 36x to the 4th. So 36 can be 6 times 6, and each 6 can be 2 times 3. So I can rewrite 36x to the 4th as 2 squared times 3 squared times x times x times x. Negative 12 can be negative 2 times 6. Negative 2 can be negative 1 times 2. And 6 can be 2 times 3. So I can rewrite this, negative 12x cubed, as negative 1 times 2 squared times 3 times x times x times x. And then 60, well, that's 2 times 30. 30 is 3 times 10, and 10 is 2 times 5. So I can rewrite 60x squared as 2 squared times 5 times x times x. What do all of these have in common? All 3 of these need to have the same things in common. Well, I see a 2 squared here, a 2 squared here, and a 2 squared here. So they all have a 2 squared in common. There's a 3 squared in the top, a 3 in the middle, but no 3 in the bottom. The bottom has a 5, but neither the top nor the middle have a 5. And they have some x's in common. They have 2 x's in common. So everything that I circled creates the greatest common factor. So 2 2's and 2 x's. Well, 2 times 2 times x is 4x squared. This 4x squared, is our greatest common factor. But we want to write down what's left so that I can be equivalent to my original polynomial. So what's left from the 36x to the 4th? A 3 squared and 2 x's. So 3 squared is 9 times x, 9x squared. Negative 1 times 3 times x, negative 3x. And then I have just a 5 left for my last term, plus 5. Just like that, we have our greatest common factor factored out from the polynomial. Now this is a little bit of work. We have some side work over here for the prime factorization, but I think it's acceptable. I think it's very organized, and I encourage my students to at least write out this if you're comfortable with writing out the prime factors without doing a tree. But I encourage them to write out this at least so that they get a visual representation of everything that is common, everything that is shared, so that they get the greatest common factor correct, and then it's also helpful because it shows you exactly what is left. As you do this more and more, you're going to get better and better at realizing what the greatest common factor is, and I would estimate at some point in the future you'll get comfortable enough to where you can just pull it out without doing any of this work. But because we're just starting, we need to show our work, we need to do some side work perhaps, and that's perfectly fine. In fact, I encourage it. Alright, and we have our last example. We're going to start it the same way, and most of it's going to be the same way until something at the very end. So we're going to start with negative 32x to the 6. Negative 32 can be negative 2 times 16. Negative 2 can be negative 1 times 2. 16 can be 4 times 4, and each of these 4 is 2 times 2. So if I wanted to rewrite negative 32x to the 6, I could rewrite it as negative 1 times 2 to the 5th times x times x times x times x times x times x. Negative 16 can be negative 4 times 4, which can be negative 1 times 4, which can be 2 times 2, and 2 times 2. So negative 16 x to the 5th can be negative 1 times 2 to the 4th times x times x times x times x times x. And 8x cubed, well 8 can be 2 times 4, and 4 can be 2 times 2. So 8x cubed can be 2 cubed times x times x times x. So what do these have in common? Well, they definitely have 3 x's in common, and they have some number of 2's in common. So the greatest that they have in common can be 3. So that means that there's going to be 1 2 left in the middle and 2 2's left in the top. So my greatest common factor is going to be 2 cubed, so 2 times 2 is 4, times 2 is 8. X, and x cubed. And what's left up here? Negative 1, x, and then 2 of these 2's. So negative 1 times 2 is negative 4. Times x times x times x is negative 4x cubed. Negative 1 times a 2 that's left over is negative 2 times x is negative 2x squared. This x is in that box. And then in this bottom one, there's nothing left. So do I just put a parenthesis and I'm done? But then if I check my answer by distributing this, I'm not going to get this top answer up here. So what we need to do, because everything's being multiplied, I can always put a multiplied by 1 in here. So I have a plus 1 left. Alright, so that's one of the two things that I wanted to discuss with this problem, that if everything gets used, it doesn't mean that term goes away. You need to have a 1 kind of as a placeholder so that when you distribute the greatest common factor in, you do end up with your original polynomial. And that's a way that you can check your answer. You can distribute this GCF into here, multiply it out, and you should get what you started with. The other thing that I want to show you is something that I would check with your teacher to see if they want you to do it. I always tell my students to make sure that the leading coefficient of their polynomial is positive. So if they were factoring this, I would want them to factor out this negative. So how are we going to get rid of that negative? Well, to factor out a negative sign, what we need to do is factor out a negative 1. So I can pull this negative 1 out here and make this negative. And if I've pulled this negative sign out, this is suddenly positive. But this negative would be distributed to each. So if I'm factoring out a negative, it's going to be taken out of all of these. So this negative 2 becomes a positive. This positive 1 becomes a negative. And I have them do this because I know what I'm going to be teaching in the future. And what I'm teaching in the future is you really want to have a positive leading coefficient. But double check with your teacher. They might be totally fine with having a negative leading coefficient here. If not, that's how you take out a negative. It basically changes the sign of each of these. Alright, so this was the very beginning introduction to factoring, to factor a greatest common factor. In the next several videos, we're going to be talking about factoring in a more traditional sense, taking a strictly quadratic and factoring it into two binomials. If you found this video helpful, consider giving it a like and consider subscribing for more math lessons. If you have a question, go ahead and comment it below and I'll do my best to answer it and help you out. Thanks, and we'll see you in the next video.